6.5 is all about percent of change, so we're going to continue our understanding with percents, looking at more word problems in real life examples, specifically focusing on percent increase and percent decrease. We have two vocab words talking about markup and discount. Markup means that when a company or a store buys a product that they're going to sell, when they mark it up, that's when they are increasing the price so that they can make a profit off of it. And then we all know what discount is that's taking away money, or a percent decrease when we are buying something. So looking here, part one is just focusing on being able to solve for percent increase and decrease. So we're looking at the problem with Mr. Sato. He sells fish at a 60% markup. He pays $3.75 per pound for salmon 1 week. So our job is to find at what price per pound he will sell it. So like I had mentioned before, the markup is the rate at which the price of merchandise increases its costs. This increase pays the merchant's costs, so they're able to make money off of the product. When we're finding percent increase, we can use our two strategies of solving, finding 1% with our equivalent fractions, or converting our percent to a decimal. So with method one, finding 1%, we'd set up our equivalent fractions. We know our percent is 60, that's always out of 100. We're trying to find what that 60% markup is, so that is our unknown, and the cost of the salmon is our total. So from here we can divide to find our 1%, in which that would be 0.0375. We're going to multiply that by 60. To get the answer of $2.25, so that's the markup, meaning the amount that's added on to the original cost that the merchant pays. So for our selling price, we have to add together those two amounts. So $3.75 plus $2.25, so the selling price would be $6. To show using method two, we're taking our percentage, turning that into a decimal, and then multiplying, where we get $2.25. So we have to add $3.75 plus $2.25 to get the selling price again of $6. So similar to what we looked at with tax and tip, that is a percent increase where you're finding the percentage and then adding it on at the end. Moving on to number two, being able to solve word problems by finding a quantity represented by a percent. So William had a length of a ribbon. He used 30% of the ribbon to wrap gifts. The remaining length of the ribbon was 385 centimeters long. He then used 25% of the ribbon to make decorations. So our job in part A is to find the original length of the ribbon. If we think about this with a bar model, we know that the entire length of the ribbon would represent 100%. 30% was used for gifts, so that means that 70% is left over, and the remaining length is 385 centimeters. So with this piece of information of this part, where we have a length and a percentage that represents it, we can use that to help us find the 100%. So our 70% is 385. We want to know what 100% is. We divide. So 1% equals 5.5, and then we multiply by 100. So the length of the ribbon was 550 centimeters. In part B, what was the remaining length of the ribbon after making the decorations? We're moving on to this piece saying that he then used 25% of the ribbon to make decorations. So 25% of what's left over, which that length would be 385. So we need to find 25% of that now being our new total. We'll divide to find our 1%. We're going to multiply by 25 to find our 25%. So 96.25 centimeters would be for decoration. So in finding the remaining length, we have to subtract. And what's left over would be 288.75 centimeters. As we look at Learns 3 and 4, we're looking at multi-step problems that involve percent increase and percent decrease. So problem number 4, the amount of water in a dispenser was 50 liters at first. After 10 minutes, it decreased to 45. Another 15 minutes later, it had decreased to 40. So in part A, finding the percent decrease in the amount of water after the first 10 minutes. Anytime we're finding a percent change, when we're asked to find that percent, we're gonna use this formula. We're taking our difference in amount from each time in each interval divided by the initial amount times 100 to make it into a percent. So anytime you're finding a percent change, finding the percent, we're taking the difference in amount divided by the initial times 100. So for part A, we're focusing on the initial to the first 10 minutes. So at 0 minutes, it was filled at 50 liters. And then after 10 minutes, it was at 45 liters. So this is an example of a decrease. You can see that because our amount is going down. So when we subtract, it's a change of 5 liters. So our 5 liters goes on top. Our initial amount was 50 liters. When we divide 5 by 50, we get 1/10 times 100 is 10%. So it was a 10% decrease. In part B, what was the percent decrease in the amount of water from 45 to 40 liters? So we were started with 45, then it switched to 40. So our change is 5 liters. With 5 liters, that's our change over the initial amount, which in this case is now 45 liters. When we divide these, we get a repeating decimal of 0.1 times 100 to make it into a percent. We'd have 11.1% repeating, and that's again a decrease. And the last learn here, learn number 5, being able to solve word problems involving fractions and percents. So 1 year, Keith's savings was $200. Andrew's savings was 4/5 of Keith's savings the next year. He then increased his savings by 20%, so we want to find the increase in dollar amounts for Andrew's savings. So Keith is $200. Andrew's going to be 4/5 of Keith's, or 4/5 times Keith's. When we multiply across, we get 800 over 5, which simplifies to $160. So that was Andrew's initial amount. Then it's increasing by 20%. So we want to find that percent increase for Andrew, or finding 20% of $160. So we could convert this to a decimal, then multiply to see that his increase was $32 after this year.